1.7, measuring variability. So we're going to get into, again, this stems off of what we did with 1.6 in looking at the median of the data, or the mean. We're going to now look at the variability. So we're going to see how the data varies that we are looking at. So we're looking at measuring the variability. Through measuring variability, we are talking about one of three things: the range, the interquartile range, and the standard deviation. Okay, these are the most common ways to measure the variability. So if we look at this, two distributions can have the same shape and center, but still look quite different due to the variability, how the data is spread out. So if you look at this data, we could say that this is roughly symmetric. It creates that little bell curve here. And same thing here. It's roughly symmetric around the center, that it creates that bell curve. But as you can see, these bell curves are just set up a little bit differently. They don't have the same exact type of data, to where if we looked at the range for the top one for Earl, and this is talking about bowling, you could say that this was here at 250 and this is 50. If you look at the range from here to here, there is a difference of 200, as opposed to looking at this one where maybe this a little bit closer to 100 and this is a little bit closer to 200, where the range here is only 100. So when looking at range, we could be talking about two sets of data that look roughly symmetric, but the range and the variability can be way, way, way different. And talking about interquartile ranges, when we break the data up into first quartile, second quartile, third quartile, and fourth quartile, looking at the first 25%, second 25%, third 25%, and then the last 25%. Well, the interquartile range goes from the middle 50%. And then we're going to spend a lot of time looking at the standard deviation when we are talking about these sets of data. So standard deviation is how far something is from the actual mean. So as we look through this and continue to go through, these will be the ways that we look at variability. So let's take a look at this next slide here and discuss. So the first things we're going to do is find and interpret the interquartile range. So the first one is talking about the range. Well, what is range? It's just simply the maximum value minus the minimum value. So the range is not resistance. It depends on a maximum and minimum values that are normally the outliers, or they could be the outliers. So it's not resistant, and it's dependent on the outliers. Another problem with the range is a measure of variability. Variability from the center is unclear. So if you look at these two sets of data on this parallel dot plot, okay, like say this is a company where they are trying to make sure that they get 70 in each object. They want 70, whatever this is, the length in millimeters, they want the length to cut at 70 millimeters. If you look at this set of data, the range for the top here would go from 68 to 72, which would be 4 centimeters. And same thing here, 72 to 68 would be 4 centimeters. The problem with the bottom set of data here is that it only hits the median point one time, whereas this one is exactly at 75 times. So that would clearly want to use this where they're only off a couple of times here in the top set of data. So again, just kind of looking at this, knowing it's not resistant, and the variability from the center is not clear. Like as we can see, this has way more times, 5 to the left and 5 to the right, as opposed to this one, which is 3 to the left and 3 to the right of our measured goal here, which was 70. So as we go on, we're going to now look at finding the interquartile range and discuss these vocabulary words here. Okay, so Quartiles, it divides the data into 4 groups, having about the same number of values. It's not always the exact same number of values, but it has about the same. So the first quartile, which we call Q1, is the median of the lower half of the data. It's the 25%. The third quartile is the median of the upper half of the data, or 75%. And of course, Q2, which we don't show, Q2 is the median. It's the actual median that we found in yesterday's lesson. So the interquartile range, or known as the IQR, is the third quartile minus the first quartile, or Q3 minus Q1. And that is known as the middle 50% of the data. Okay, so the IQR is the middle 50% of the data. And quartiles and interquartile range are resistant, again, because we're dealing with the median here, which is more of a count than it is the average of. So the outliers do not affect it as much when we're looking at the IQR. Okay, so we're going to go through and do an example where we are finding actually, let's look at an example before we do one. So right here, find and interpret the IQR, or the interquartile range. So if we look at this, you can see that the first quartile, what we're talking about is the amount collected. We don't know what this is. It just gives us everything. But you can see Q1 is here at about 23 or 24. The third quartile here is at about 32. So if we just took the range, it'd be 39 minus 19, and we would get 20. But right here, we can see the first quartile is this bar right here. Okay, and we could say that this is about the first 25% of the data. The median, which is the second quartile, or Q2, there's another 25%, another 25%, and another 25%. And you can see this always doesn't completely match up, but there's 3 sets of data in the last quartile, 3 sets of data here, 3 sets of data here, and 3 sets of data here. Okay, so what we do is we look at this from Q1 to Q3 is what we call the IQR. Okay, it's just the middle 50%. And we can analyze this data as we go through this. But this is kind of just an idea of the shape of what we're dealing with when we talk about IQR and those things. So the next slide here, we're actually going to do it. We're going to use the applet. Of course, we could list all these out, find the median, and then find the median of the upper half and find the median of the second half to find all those things. We're going to use the applet to help us out and actually do the math for us. And again, using a lot of the technology. So a healthy range to choose from. Here's data on the amount of fat in grams in 9 different McDonald's fish and chicken sandwiches. So we have this number of sandwiches, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to take those and put those into my stats applet. So we go to the stat applet. We are in one quantitative variable. I'm not so much worried about the table, so I'm not going to give it the name, but I'm going to enter the data here. So 19, you can take a picture of this. 16, 22, 33, 27, 9, 20, 14, and 19 grams of fat. So begin analysis. Don't care about the dot plot here, but I do care about this information right here. Okay, so as you can see, it gives me the mean, the standard deviation, which we'll talk about in the second objective, the minimum, the maximum, and then my Q1 and my Q3. So here are the important values that we need to write down. Q1 is 15. Okay, so quartile 1 is 15. Quartile 3 was, where'd you go? Right here, 24.5. And the IQR, which is Q3 minus Q1, was 24.5 minus 15, which is equal to 9.5 grams. So now when we analyze this, we would say the range of the middle half, and you could also say middle 50%, okay, the middle half of the fat in chicken and fish and chicken sandwiches, so in fish and chicken sandwiches, is 9.5 grams. Okay, so if it asks you to find the interquartile range, take Q3 minus Q1, and then interpret the value, just really tells me the range of the middle half. So you've got to say the range of the middle half, okay, and then what we're discussing, and then give me what that range is. So that is the first example there, and that's the first thing we're looking at is the IQR, finding the different quartiles and being able to find the range.